Challenge yourself to answer this tough protein folding MCAT question. If you like the content on my page, check out my MCAT community. A solution of proteins is slowly heated. Calorimetry detects two distinct phases. In the first phase, the measured delta H is positive. At higher temperatures in the second phase, the measured delta H becomes negative. Which of the following best explains these two observations? First, notice that each answer option is mentioning unfolding of proteins and aggregation of those unfolded proteins. When you heat up a solution of proteins, eventually the proteins unfold. When you heat up a solution, the molecules start to move around more quickly. In our folded protein right here, you can view this as though the protein starts to vibrate faster and faster, so it's moving back and forth as shown by these double-sided arrows. As it does this, the bonds that are holding the protein folded together start to break. This bond here, for example, is a positive ion attracted to a negative ion. If the two sides start to shake too much, eventually that bond will not be strong enough to stick together, and that's going to break apart. That's going to happen for all of the different bonds that hold this entire protein together, and eventually you'll be left with just a straight chain of amino acids like we see at the bottom there. Anytime you are breaking bonds, that requires an input of energy. So unfolding a protein requires inputting energy, which means that the delta H is positive when we unfold a protein. So we know that the first phase has to correspond to unfolding a protein. So our answer is either A or C. After we unfold the protein, we continue to heat it up. So since we're continuing to heat it up, we know that the protein's not refolding because it could only refold if we lower that temperature. We know that the delta H is negative as we continue to heat this, and we can only see a negative delta H if bonds are forming, because forming bonds always releases energy. So we're releasing energy, but we know that the protein is not refolding. So what's going on? When you denature a protein and you end up with a straight chain of amino acids, sometimes these chains can aggregate together. This means that they fold up and they clump up in random ways. And in order to clump up like that, they'll be forming a bunch of new intermolecular interactions. Let's imagine this O right here, which has a partial negative charge. That could form a new interaction with this hydrogen over here that has a partial positive charge. But these interactions are not going to be nice and organized like they are during normal protein folding. That means it doesn't result in nice beta sheets like that or alpha helices. It's just a clump of amino acids. But during the formation of these random intermolecular interactions, we will start to see a release of energy. That means that the second phase must be protein aggregation.